Hello, wonderful people. In this tutorial, we'll be covering how to convert your mouse sensitivity into Unity from other games like Valorant or Counter-Strike. Timestamps are in the description. First, let's create an input asset and call it whatever you want. We'll call our action map player and our action called look. Make sure it has a value type of vector2 and that we have a control scheme referencing the mouse. And also that the action is used in that control scheme. Now let's add a new script, call it player rotator. Add a reference for two transforms, one for pitch, which is the up and down rotation, and one for yaw, which is the left and right rotation. Add a reference for our input, which we will enable in onEnable and disable in onDisable. Let's also modify our cursor lock state in these methods. Now let's add a private vector2 to track and modify our current rotation. Then in the update, we'll read our input as a vector2 and multiply it by a sensitivity field. We'll need to clamp our rotation to make sure we don't flip upside down, but let's do that after we have the first bit set up. The easiest way I've found to handle this kind of rotation to a transform is to modify the local rotation using quaternion.euler. The x and y axes of our mouse input should be swapped from the x and y axes of our transforms. The way I like to think of this is if you stab your head through the top and bottom, representing the y-axis, you can only move your head left and right. And if you stab your head through the sides, or the x-axis, you can only move your head up and down. We'll also need to invert the y-axis, unless you're some psychopath who likes inverted y. Now let's assign our references in the inspector and do a quick test, just making sure we're actually looking in the directions that we want. And we are, so let's clamp our rotations. For our left and right look, I like to use this mod equals 360 approach, just to keep the values at a predictable level. And for the up and down, since we're modifying a variable, we can just clamp the y component like so. I've personally found that without this epsilon field, it can still sometimes break the bounds that we want due to floating point precision, even when using float.epsilon. So I just use something like this, but you can experiment with a value that works for you. To accomplish this conversion, I'll be using a third-party sensitivity conversion tool. And from it, we'll take this inches per 360 value, and after reverse engineering with some math, our result will be a constant that will represent the conversion factor for our given game. Now to explain the math, initially what we want is to convert our input, being in delta dots, to a delta degrees by which to rotate our transforms by, given dots per inch, inches per 360, and a reference sensitivity. First, if we multiply dots per inch and inches per 360, we can cancel the top and bottom, and our result is dots per 360, or dots per full rotation. Next, remember that division is just multiplication by the inverse, so if we multiply our delta dots input by the inverse of the previous product, now being rotations per dot, it results in delta rotations, which we can multiply by 360 to get that delta degrees that we were looking for before. Writing this out using the original variables, this is what our formula looks like, but we still have to compensate for the sensitivity of the game. Fortunately, this is as easy as multiplying the top and bottom by that sensitivity, and in practice, the top sensitivity will be our desired game sensitivity, while the bottom is a constant, which results in a ratio reflective of whatever game we want to be converting from. Let's create another script, which I'll call sensitivity utility, which will inherit from editor window. I like to wrap all of my editor code inside preprocessor directives like this, so I can avoid creating an editor folder and dealing with editor assemblies when importing projects. Create a static method, name's not important, we just need to call editorWindow.getWindow on this type, then add a menu item attribute so we can access it from the editor. Create 3 fields, one for DPI, one for inches per 360, and one for the reference sensitivity. Being in an editor window, we have to manually draw the fields in the onGUI method. So the formula that we came up with to get our desired constant is this: 360 divided by the product of DPI times inches per 360 and the reference sensitivity. Then, to display our output, I'll use a selectable label and modify the style a bit. Now in our player rotator script, add an extra field for the conversion factor and multiply it into our input. Finally, in the editor, open the editor window we created and copy the inches per 360 value from the third-party tool and fill in the fields for your own setup. Don't forget to do the same for your rotator script. And that's it. Now to prove this actually works, albeit in a very non-scientific way, I marked on my desk the distance to 180 in Valorant with these game settings. And here it is in our game. Thanks for watching. This is the first of hopefully many tutorials, so I would greatly appreciate any feedback that you have to give. Let me know in the comments if there was anything you liked or disliked about this video so that I can improve on the next one. And wherever you are, have a wonderful day.